Hey guys, Brian here. Welcome back to the shop. I'm in here today to do a little valve work. If you're a long-time follower of my channel, you've seen this operation done before. Well, more or less. This is a little different, but all jobs are. Anyway, when I was getting ready to start on this, setting it up, I thought I would give you a look at an engine building no-no. Perhaps it's a tip or trick, or mainly it's only to do with rather large engines. But if you look in this piston, the snap ring in it is turned sideways, and that is a no-no, because what can happen is when this piston reaches top dead center or bottom dead center, the inertial force will make it try to close one side or the other side, and the snap ring can fly out and it'll wreck your engine. If you don't believe this is true, try it on a big 822 cylinder and run it at about 1500 RPMs, and probably within 10 minutes it will destroy itself. So you always want the openings at the bottom. So something like that is the proper way to install snap rings and pistons. Anyway, I'm taking this one apart. Here's your little billet connecting rod. High performance racy stuff here. It's extended length over a stalker. So there's a stock rod, and there's the lengthened aftermarket rod. Guess I should put it on the same way. So there's your difference right there. This is a 8 3/4, and that other one's a 9 1/2, I think. Otherwise, they are very similar copies of one another. Of course, they got to fit in the same spot. So this is a early John Deere connecting rod, which is not TP'd. It's old style, even. Later rods are TP'd, also have a much bigger hole for a bigger wrist pin. These are not generally used in high performance applications because these are designed for low speed and lots of power, where the piston's always pushing down and you don't have centrifugal force trying to tear the top off. So this rod's not preferred at high RPM. These here are more preferred at high RPM because they have the same amount of meat on the top and the bottom, so the wrist pin doesn't try and tear out of the rod and throw your pistons out and blow outside the block. That's a bad day. These factory ones were gun drilled pressure lube. They went away from that and just went to splash lube, which is the same way this billet rod is made. So I don't have anything to do with those. I just had it for mocking up for building the engine for the customer. Right now I got to cut some deeper valve reliefs in those pistons so that they will work with the camshaft you got. So this is a aftermarket Ford's aluminum alloy piston for John Deere overbore. They're essentially just a blown out version of a stock one. One difference being these don't have inserted steel ringland grooves with the V's like you see in a stock piston for higher use. These are just billets cut out so that you can make anything you want easily and cheaply. Well, as cheap as this kind of stuff is, more so than you know, a production run of factory parts that have to last thousands of hours. The run time on these is in the hundreds of hours range at most, probably, before something will happen to these and they'll have to be replaced anyway. So see their billet, their tool pass in there. Clearly a CNC operation. This is how I get the piston set up. Just put it in the vise with the V-block flush, and that'll center the piston this way. Let's take a parallel and go across the jaws out here and the wrist pin, and twist it till the face of the wrist pin's square, and twist it on me. And that's that. So, ready to fire the mill up and make some cuts. I've already been doing some of these while I got all the aluminum here, but I'll let you follow along. I got to do it with 2 end mills because the only 2 1/4 inch cutter I have, which is not a very good one at that, and needs sharpened. Maybe I can take this over to Steve's and get him to touch it up for me. But it doesn't center cut, and part of that is over top of the bowl, so it leaves a spot I have to clean off with the end mill. But what I do is, rather than change tools often, I just go ahead and put the centers back, cut them, and then swap out and cut that, and then I'll do the next piston still with that first, and then clean it back up with that. So I just got to pay attention to my depths, because these tools are not the same height, so that I stop in the same point and get a decent blend out of them. So let me fire the mill up and we'll get to cutting. It's really cold in here, and I don't have the American rotary phase converter up here anymore, the 50. I'm running on my 20 on this 25 horse machine, so it really doesn't like to start. But let's give it a go. job there. You can see a little chatter in it from that dull cutter, but still not looking too bad. Be plenty good enough for what they're going to do. Bites the dust. Well, that's got the 6 of these finished up. Hope this was interesting to you and maybe you learned something about building an engine. Ultimately, I'd recommend using gaplet snap rings. The wire locks, I think, are far superior to a snap ring like this, my personal taste. But this is what this particular customer has, and having a snap ring come out and a wrist pin go into your cylinder wall, that makes a mess out of things. That's those big engines. That was a fairly common thing on the big 2 cylinders if they got to overspeeding was to throw these snap rings out, and a lot of times that was the cause, was the way they were oriented. So, thanks for watching, thanks for subscribing, I'll catch y'all later.